What's up, Open School? Mr. Kim here with an introduction to graphing inequalities. I'm going to play some cool jazz, and if keeps moving over me the way it is, I might just have to sing a line or two. So we're considering graphing inequalities. I'm going to review the way signs work. Got a better picture of it here. So if we have a greater than sign, it goes in this direction right here, and the other sign is less than right here. Now some people remember this by saying the mouth of the sign always points to the larger number, or the larger part of the sign opens to the larger number, and the smaller opening always points to the smaller number. The way I remember this is the sign that looks like the shape of the L, like kind of like an L, is the sign that means less than. The sign that goes in the direction of the L is the sign that means less than. Now we also need to know that if it contains a line underneath it, that says greater than or equal to, and down here less than or equal to, let me get a color here, less than or equal to. So a straight line at the bottom of the sign, and you can think of that as being an equal sign, kind of like it's fallen down. It was an equal sign that fell down, and so it means greater than or equal to. So let's take a look at how we would graph some of these inequalities on a number line. So on a number line, let's get rid of all the extraneous material here. On a number line, whoops, get rid of that too. If we have a sign that says here that x is greater than -2. So it's pointing, the mouth, the open part, is pointing towards the x, so the x is greater than -2. So the way we would graph this is we would draw a circle around -2 to show that it's not included in what we're graphing, because it's not greater than or equal to, kind of looks like that's what I was doing there. It's not greater than or equal to -2, it simply is greater than -2, and then we would go ahead and graph in everything that was greater than -2. So if it is just greater than, it doesn't include the -2, so we put a hollow circle around it to show it's not included. Now Mr. Elliot intuitively pointed out that the direction that the inequality sign is pointing is the direction that we draw our graph. Now what's the next one say? It says 4 is greater than or equal to A. And if 4 is greater than or equal to A, then A has to be less than or equal to 4. So we actually have to consider that as being the opposite statement. But 4 is included in the number line, so it's colored in, and it is greater than or equal to A, so A has to be less than 4. So we could rewrite that as A is less than or equal to 4. So when we rewrite and put the variable first, that's what we end up with. And by convention, we want to write our inequalities as our equations. As with our equations, we write the variable first. So let's take a look at how this plays itself out. As soon as I get this cleaned up here. So if I make a couple more of these, I'm going to say that 5 is less than or equal to, and I'll use the variable b. 5 is less than or equal to b, so when I rewrite it, b is greater than or equal to 5. Whoops. B is greater than or equal to 5. So it'd come out here to 5. I colored in because it includes 5. And it is greater than or equal to 5. Get a couple more of these down. How about if n is less than -2? So I can't include number -2 because it is not equal to -2. It's simply less than -2. So all the numbers less than -2, not including -2. Right, how about if we go just a couple more of these? How about if we have x is greater than or equal to 0. If x is greater than or equal to 0, it includes 0 because it's greater than or equal to 0, and the greater than sign points this way, so I include all numbers greater than 0 out to infinity. So that's a look at some of the ways, some of the procedures, the review of how we would graph inequalities. Hope this helped. Coming up next, solving and graphing one-step inequalities.